The V model is a term applied to a range of models, from a conceptual model designed to produce a simplified understanding of the complexity associated with systems development to detailed, rigorous development lifecycle models and project management models. There are several radically different forms of the V model, and this creates considerable confusion. The V model falls into three broad categories. Firstly, there is the German V model, Das V model, the official project management methodology of the German government. It is roughly equivalent to PRINCE2, but more directly relevant to software development. What is probably the earliest use of the V model as a basis for a standard is Software Development Standard for the German Federal Armed Forces, 1992. The key attribute of using a V representation was to require proof that the products on the right side of the V were acceptable by the appropriate test and integration organization implementing the left side of the V. Less than German Directive 250, Software Development Standard for the German Federal Armed Forces, V model, Software Lifecycle Process Model, August 1992. Greater than in the UK, and throughout the testing community worldwide, the V model is widely seen as a vaguer, illustrative depiction of the software development process, as described in the ISTQB Foundation syllabus for software testers. There is no single, accepted definition of this model, which is more directly covered in the alternative article on the V model. There are therefore multiple variations of this version. This problem must be borne in mind when discussing the V model. Thirdly, like Germany, the US also has a government standard V model, which dates back about 20 years, like its German counterpart. Its scope is rather narrower, being a systems development lifecycle model, but far more detailed and more rigorous than most UK practitioners and testers would understand by the V model. Overview. The V model is a graphical representation of the systems development lifecycle. It summarizes the main steps to be taken in conjunction with the corresponding deliverables within computerized system validation framework. The V represents the sequence of steps in a project lifecycle development. It describes the activities to be performed and the results that have to be produced during product development. The left side of the V represents the decomposition of requirements and creation of system specifications. The right side of the V represents integration of parts and the validation. However, requirements need to be validated first against the higher-level requirements or user needs. Furthermore, there is also something as validation of system models. This can partially be done at the left side also. To claim that validation only occurs at the right side may not be correct. The easiest way is to say that verification is always against the requirements and validation always against the real world or the user needs. It is sometimes said that validation can be expressed by the query, "Are you building the right thing?" and verification by, "Are you building it right?" In practice, the usage of these terms varies. Sometimes they are even used interchangeably. The PMBOK Guide, an IEEE standard, defines them as follows in its 4th edition. Validation: the assurance that a product, service, or system meets the needs of the customer and other identified stakeholders. It often involves acceptance and suitability with external customers. Contrast with verification. Verification: the evaluation of whether or not a product, service, or system complies with a regulation, requirement, specification, or imposed condition. It is often an internal process. Contrast with validation. Objectives: the V model provides guidance for the planning and realization of projects. The following objectives are intended to be achieved by a project execution. Minimization of project risks. The V model improves project transparency and project control by specifying standardized approaches and describing the corresponding results and responsible roles. It permits an early recognition of planning deviations and risks and improves process management, thus reducing the project risk. Improvement and guarantee of quality. As a standardized process model, the V model ensures that the results to be provided are complete and have the desired quality. Defined interim results can be checked at an early stage. Uniform product contents will improve readability, understandability and verifiability. Reduction of total cost over the entire project and system lifecycle. The effort for the development, production, operation and maintenance of a system can be calculated, estimated and controlled in a transparent manner by applying a standardized process model. The results obtained are uniform and easily retraced. This reduces the acquirer's dependency on the supplier and the effort for subsequent activities and projects. Improvement of communication between all stakeholders. The standardized and uniform description of all relevant elements and terms is the basis for the mutual understanding between all stakeholders. Thus, the frictional loss between user, acquirer, supplier and developer is reduced. V model topics. Systems engineering and verification. The systems engineering process provides a path for improving the cost-effectiveness of complex systems is experienced by the system owner over the entire life of the system, from conception to retirement. It involved early and comprehensive identification of goals, a concept of operations that describes user needs and the operating environment. Thorough and testable system requirements, detailed design, implementation, rigorous acceptance testing of the implemented system to ensure it meets the stated requirements, measuring its effectiveness in addressing goals, ongoing operation and maintenance, system upgrades over time, and eventual retirement. The process emphasizes requirements-driven design and testing. All design elements and acceptance tests must be traceable to one or more system requirements, and every requirement must be addressed by at least one design element and acceptance test. Such rigor ensures nothing is done unnecessarily and everything that is necessary is accomplished. The two-stream specification stream. The specification stream mainly consists of user requirement specifications, functional requirements specifications, design specifications, testing stream. The testing stream generally consists of installation qualification, operational qualification, performance qualification. The development stream can consist of customization, configuration or coding. Applications. The V model is used to regulate the software development process within the German federal administration. Nowadays it is still the standard for German federal administration and defense projects, as well as software developers within the region. The concept of the V model was developed simultaneously, but independently, in Germany and in the United States in the late 1980s. The German V model was originally developed by IABG in Otterbrunn, near Munich, in cooperation with the Federal Office for Defense Technology and Procurement in Koblenz, for the Federal Ministry of Defense. It was taken over by the Federal Ministry of the Interior for the Civilian Public Authorities domain in summer 1992. The US V model, as documented in the 1991 Proceedings for the National Council on Systems Engineering, was developed for satellite systems involving hardware, software, and human interaction. The V model first appeared at Hughes Aircraft circa 1982 as part of the pre-proposal effort for the FAA Advanced Automation System program. It eventually formed the test strategy for the Hughes AAS design competition phase proposal. It was created to show the test and integration approach, which was driven by new challenges to surface latent defects in the software. The need for this new level of latent defect detection was driven by the goal to start automating the thinking and planning processes of the air traffic controller as envisioned by the Automated En Route Air Traffic Control program. The reason the V is so powerful comes from the Hughes culture of coupling all text and analysis to multidimensional images. It was the foundation of sequential thematic organization of publications created by Hughes in 1963 and used until Hughes was divested by the Howard Hughes Medical Institute in 1985. It has now found widespread application in commercial as well as defense programs. Its primary use is in project management and throughout the project lifecycle. One fundamental characteristic of the USV model is that time and maturity move from left to right and one cannot move back in time. All iteration is along a vertical line to higher or lower levels in the system hierarchy, as shown in the figure. This has proven to be an important aspect of the model. The expansion of the model to a dual V concept is treated in reference. As the V model is publicly available, many companies also use it. In project management, it is a method comparable to PRINCE2 and describes methods for project management as well as methods for system development. The V model, while rigid in process, can be very flexible in application, especially as it pertains to the scope outside of the realm of the system development lifecycle normal parameters. Advantages. These are the advantages V model offers in front of other systems development models. The users of the V model participate in the development and maintenance of the V model. A change control board publicly maintains the V model. The change control board meets anywhere from every day to weekly and processes all change requests received during system development and test. The V model provides concrete assistance on how to implement an activity and its work steps, defining explicitly the events needed to complete a work step. Each activity schema contains instructions, recommendations, and detailed explanations of the activity. Limits. The following aspects are not covered by the V model. They must be regulated in addition, or the V model must be adapted accordingly. The placing of contracts for services is not regulated. The organization and execution of operation, maintenance, repair and disposal of the system are not covered by the V model. However, planning and preparation of a concept for these tasks are regulated in the V model. The V model addresses software development within a project rather than a whole organization.